Here I am going to show you how to work out the sine, cosine and tangent values of two of the most important angles that come up in your work, 30 degrees and 60 degrees, or in radian language, pi by 6 and pi by 3. The first thing you do is draw an equilateral triangle with sides of length 2 units. M along OB there is the midpoint of OB, and so OM and MB are both 1 unit each. Now, since this is an equilateral triangle, we know straight away something about each angle, don't we? It's going to be 60 degrees. Then, if we drop a perpendicular down from the top angle C down to the line OB, it will hit at M. And then the smaller angle up the top of C, we've got two of them now, so the angle OCM will be half of the original bigger angle at C, which was originally 60, so the smaller angle there is going to be 30 degrees. So there we know all our angles now. We've got 30 degrees, 60 degrees, each of the angles at M is a right angle. We can work out many of these trigonometry ratios. But to help us get them all, we need one more value. We need the length of the side CM. That's easy enough with Pythagoras. We know that 1 squared plus CM squared equals 2 squared. So CM is just the square root of 2 squared minus 1 squared, which is the square root of 3. So there we have it. We've got all the sides, all the angles, and we can just go ahead now using SOHCAHTOA and find the cosine, sine and tangent of pi by 3 and pi by 6. Let's start with the first one. Start down here. Cosine of 60 is adjacent over hypotenuse. So cosine of 60, cosine of pi by 3 is adjacent 1 divided by hypotenuse 2, 1 over 2, and so on. We can very quickly fill out the rest of those values. Now let me show you one more triangle for the 45 degrees. So then you'll be able to do 30, 45 and 60 degrees all just by sketching these quick triangles. So you don't have to memorize the values, you don't have to look them up. You've just got them very, very quickly from these quick sketches. So let's move on to the next triangle. This triangle is even easier. It's just a right-angled triangle, well, a right-angled isosceles triangle with the two shorter sides each being 1 unit. And if it's isosceles, we know straight away something about the other two angles. So one is a right angle, the other two must be 45 degrees, or pi by 4. We need the length of this OC side, the hypotenuse. That's easy with Pythagoras. 1 squared plus 1 squared. And take the square root of that, and there we have it. Root 2. Very quick. And now we can just work out the sine, cosine and tangent for 45 degrees, pi by 4. So cos 45 adjacent over hypotenuse, 1 over root 2. Sine 45 opposite over hypotenuse, again 1 over root 2, they're the same. Tan 45, or tan pi by 4, opposite over adjacent, 1 over 1, which is 1. So there's just with these two very quick triangles, using Pythagoras quickly, you can get all these basic trig ratios that you need. Because whenever a question asks you to solve a problem exactly, it is these values, so root 3 over 2, 1 over root 2, and so on, that you must use, not the ones stored in the calculator, because the calculator values have been rounded, and therefore they are not exact. So you must use these, and you just leave your answer in terms of root 3 over 2. You don't work it out at all.